Now we can get into the meat of the topics for today, which is pass by reference versus pass by value. So pass by value and pass by reference has to do with how we pass variables into a function. So when we're using variables as function arguments. And it's two different ways of thinking about how you pass information to a function definition. And actually, I'll strengthen that statement a bit and say it's not just about how you think about it, it's about how the computer and how the language actually passes something into a function. So when we pass an argument by reference, changes that you make to the argument actually apply to the thing that was passed in. And we say it's a reference because you actually pass in a reference to the original thing that's being passed in. So here you can see when this coffee cup is passed by reference into this function, when we fill up the coffee cup, we're filling, like the reference that's given, we're actually filling up the original as well, because they refer to the same thing, hence pass by reference, because the thing that you're passing in is a reference to the original. Whereas when you pass by value, you're actually making a copy of the argument and it's being passed into the function. And by the way, here when I say you make a copy, as I'll show you in a second in our examples, this isn't talking about you actually making a copy of a new variable. Python actually already does this for you for certain variable types. And that's what you'll see in a second here. So these are two different ways of how a computer actually passes the information to a function definition. Pass by value is what we'll talk about first. And when we pass something by value, Python will make a copy of the value that's in that variable and pass that copy to the function. So the result of that is that any operations that happen inside of our function don't modify the original variable. And in Python, it's all of these immutable types, the integer, the float, the string, and the Boolean, that are always passed by value, meaning whenever you call a function and you pass in a float, an integer, a string, or a Boolean, the value that's assigned to the parameter inside of the function, when the function is being executed, is a copy of the argument that's passed in. It isn't the original. And so if we look at examples here, here's a couple of examples of pass by value. When we call add2, with a, when you call add2 and you pass in this digit 5, what happens is because this is an immutable type, this is an integer, the value that gets assigned to num inside of our function is actually a copy of 5. So it's easiest for me to just show you what happens when I run this code. So here, to be really clear, I'll print result digit when I run this code, you can see that the result that's returned is 7, but the original value of digit is unchanged. It's still 5 after the function. And if we take a look in Python Tutor, it'll be clear why this happens. So looking at this environment diagram, as we step through the code here, when we call the add2 function, notice that the number 5 gets written down here in the local frame, and changes that we make update the value in the local frame only. So the value 5 gets replaced with a new value 7 in the local frame. And this is pass by value because this is a brand new value that gets stored here. It's not the same 5 that was out here. It's not the same variable here. And so we return 7 and we print the result 7, 5. Same thing for this other example. A string is another example of a type that is passed by value when you call a function, meaning you don't pass any sort of reference to the original variable or the original value, you actually make a copy. You pass in, by calling add world word, phrase gets assigned a copy of the value of the argument. And so if we run this code, when we print out result, the result will be hello world, because our add world function returns hello plus world. But if we print out the original word, the word is still hello. This is in contrast to pass by reference. So pass by reference means that you pass a pointer, the pointer of a variable to the function. And so any steps that you take inside of the function definition do actually modify the original variable value. And I want to first jump to this slide and show you, what do I mean by pointer? So a pointer is just a place in memory. And in Python tutor, we see these pointers are represented by these arrows. So whenever you see this arrow, that's actually a pointer. And that just means that inside of this box, what you actually write down on your piece of notebook paper in the global frame, or whatever frame you're in, is you write down the address in memory of some place where you actually find your data, your variable value. And so in Python specifically, it is the variable type that determines whether this argument is going to be passed by a reference or passed by value. And in fact, all of the immutable types are always passed by value, whereas all of the mutable types are always passed by reference. And so it's lists and dictionaries that when you call a function are always given as a reference, because they're always represented by these pointers. Or they are, the variables themselves are a pointer to the complicated kind of data in memory. So we can take a look at some examples here of pass by reference. So when we call add to nums, the function add to nums here, so we create a list of numbers 1, 2, 3, 4, result equals add to numbers, and print the result, print numbers. Inside of our function, we do nums.append to. The crucial thing here is that because lists are passed by reference, that means that when you do nums.append to, you are actually modifying the list that was passed in. It isn't a copy because it isn't passed by value. It is the actual original list. And we can see that if we go to Python tutor. As I step through this code, numbers is a list in memory in the global frame when we create it. And when we call add to, given the numbers, notice that the very first thing that happens is the parameter nums gets created, and the value of this parameter is a pointer to the same list. So this is how we actually see that this is passed by reference, because the variable in the frame, in the function, refers to the same list that was passed in. It isn't a copy. If this were passed by value, then nums would point to a brand new list that also holds 1, 2, 3, 4. And so because in Python, all mutable types are pass by reference, when you pass in a mutable type like a list or a dictionary into this function, the parameter variable inside of the function refers to the same list as what was passed in, as the list that was used as an argument. And so this means that when you make changes inside, when you run this line, nums.append to, come over here, you can see that a 2 gets added to the list. And this list is the same list that numbers refers to in the global frame. And so when we return nums, we're returning a pointer to the original list. And so now the result, when we print it, is 1, 2, 3, 4, 2, which makes sense. We append 2 and we return the numbers. But crucially, the original numbers list is also 1, 2, 3, 4, 2, because they actually refer to the same thing, because we passed the reference to the same object in memory. And here we have another example. This removes 2 does the same thing. So remove 2, given some list, we call remove 2. exact same thing happens. Inside of the function, because this is a mutable type, you pass the reference. You don't pass a copy of the value, pass by value, you pass a reference to the same exact value. And so any changes you make inside the function actually propagate to the value that was passed in as an argument. And here I have an example with dictionaries. Dictionaries are also a mutable type, and so therefore they're also passed by reference. And so when you call a function and you pass in a dictionary, any changes you make inside actually affect the dictionary that was passed in, because we pass in a reference. It's passed by reference. So for adding a character, for removing, adding a key, removing a key, both work the same way. You might be wondering now, why this complication? Like, why does pass by reference even exist? Why isn't everything passed by value? Because we could kind of make things work if we always passed in a copy of the argument. So if we set the parameter equal to a copy of the argument every time, if that's what Python did, why isn't everything just passed by value? The reason is that lists, dictionaries, and these other mutable types could be super large. You could have a list with thousands of items. Or a dictionary of the entire English language. So it would be extremely expensive for the computer to make copies of the entire mutable objects each time it's passed into the function, because these mutable objects can get kind of big. And so we have this idea of pass by reference because it's much more efficient to just say, oh yeah, here's like, you can go find the dictionary over there that I'm passing in. I don't have to make a copy of that dictionary for you. So that's why Python does this for mutable objects. For these more complicated objects, it's much cheaper to pass a reference than it is to pass by value.